Okay, thanks, Jen. Real pleasure to be joining you all today. I missed the first two this year, but I just put up here the schedule. I actually saw part of one of them and missed the other one. So this is I guess the third out of six. I guess we had an overview one as well back in prior to that, maybe in September. So yes, I teach meteorology at Metro State in Denver, and we did host the second annual one, and we had a bunch of people drove up from Texas dodging tornadoes on the way. So it was really exciting last May. I'm acting kind of as host again this coming year in Boulder this time. So I'm going to launch in and kind of say a little bit about GLOBE and analyzing GLOBE data. Whenever I talk to people about GLOBE data, I really emphasize the G and the O. You know, the O, heart of GLOBE, is the observations and really going out and taking that data. So I'm really start out. And then the G, the global, really looking at those collaboration and using data from around the world. So very briefly, where does this analyze data? So we're kind of in the middle of the scientific process. We can kind of think about the scientific method or process in different ways, and maybe a little bit different for us in observational science as compared with a laboratory science. Some things we cannot reproduce exactly in controlled lab experiences. So I stole this from the GLOBE data or GLOBE website on the science symposia. So just kind of thinking about this, what are some of the things we can look at in analyzing data? So I think if you found your way to this webinar, you probably have this as well. Just in the website under the for the SRS, you should be able to find some information, and this just kind of summarizes where we are in terms of analyzing data. So we just finished up kind of revamping the rubric for the projects. So I think I don't know how many of you have participated in the SRS. I think one of the things we really are interested in doing for these reviews is it's more like a conference, like AGU, a poster session there. We're simulating that rather than a traditional science fair. And part of that then is going to have the chance for the students really to talk to scientists. So we recruit scientists, and you know, scientists, I think we're a little quirky maybe. We have our own biases on what we think is interesting and not necessarily what the students think are interesting. But these are kind of throughout the rubric, several things that kind of relate to data analysis and making graphs. So I've kind of put it in here. So it's kind of from the beginning part, already thinking about the data all the way to making the poster. So to some extent, I want to encourage you all, if you haven't already gone back to a webinar from 2016, I captured this image from the video, so it's a little blurry, but only show this just to encourage you all to go back and look at this really excellent webinar, really looking at different types of graph types. And I'll hit on a little bit of some of the aspects relating to this presentation as well. So when students go and look at graph types, one of the things I'll mention, some of the feedback from our science reviewers is relative lack of diversity in terms of graph types. You can imagine maybe what graph types we see a lot of, the bar graphs. So these are a couple more of the slides she had, just to kind of think about why are we graphing, what is the the purpose or goal behind doing the graphing, and really we can kind of look at this to tell a story. But we want to look at patterns, identify those research questions. So we want a graph that is linked back to what is the research question. If it's not answering the research question, it shouldn't be there in terms of the graph. So there needs to be that connection. One of the things, if you have a chance to look back at Jackie's presentation, one of the things she emphasizes, and I do as well, is not just how things are different, but the variability even at one location. In terms of the graph components, I think maybe just think about these things. A couple of these, when we look at some of the example graphs that were used in the past at the SRS, looking at not only the graph type, and that's what I want to emphasize mostly on that, but some of these things we might think more related not to the data analysis, but more to the poster presentation. And what does the graph look like? So it's not really the data analysis, but it's kind of connected because it's going back and telling the story. So do you have the right axes? Do you have the units? Those things, sometimes it's a little hard to tell without prompting the students whether that data is plotted correctly. Occasionally you can ask some questions about it and it turns out, oh, that data actually wasn't plotted correctly. So I think those are the things I wanted to emphasize. And just a couple more things that Jackie presented that also is on the Globe SRS website, kind of right underneath the resources for this webinar. So a couple things. This is a graph choice chart. So kind of giving some ideas of how do you decide what's the appropriate graph type to use. And so we can think about things like histograms, scatter plots, pie charts, and I'll talk about a few of these types, maybe not comprehensively. I'll talk about a few of these, maybe so that we don't just look at bar graphs. Some cases, bar graphs are the right type, but in other cases, we can use other types. And to some extent, it makes it appealing and intellectually interesting to have more than one graph on the same project. So here are just some tips related to those. And on the right, you see these are some criteria for information that should be on a graph. So I think, let me stop at this point, see if there are any questions, or I'm kind of curious how many of you have already seen Jackie's presentation, were able to find the time to look through that. I know it's a busy time for me. I was struggling to get this ready in time, kind of at the end of the semester. So let me just open that up and see if there's any quick questions before I go on.
I did put the link to the webinar that you're referring to, Rich, in the chat box for people if they wanted to bookmark that for later.
Fantastic. Okay, sure. I guess I'll go on. The next thing I wanted to go in and tell you a little bit about what is the feedback from the reviewers. So I think this would be really interesting for students maybe to think about. They're looking at the rubric and thinking about what they want to do. Maybe they don't really have an idea of how a scientist is going to look at that. And so maybe this gives a little bit of insight in terms of maybe what some scientists are looking at when they're looking at these research posters. So kind of divided some of the comments into some categories. So the first one is going back to the data type. Okay, so I showed you the graph where there's several different data types that you may consider for different things. So these are a few comments I extracted out of the reviewer comments. Some of these are saying, well, it would be better as a line graph or something rather than bar graph. I think in particular, there are some, if we have the bar graph, I think in terms of a relationship, seeing how different variables vary compared with each other, probably a bar graph is not the most appropriate. One of the people said, could have used something like Scatterplot. And so I'll talk a little bit about Scatterplot. This is probably good at the 9 to 12 level, might be a little advanced for the 5 to 8 level, but I guess I have seen some ambitious students that may not be the case. So that's kind of my impression, that we might have different levels. One of the things we saw a lot, I think it's a compromise to some extent. We want the students to pick something that they can answer the question, but oftentimes they just haven't collected enough data to really answer the question. So these are some of the comments I think relate to that. The first one, I think, kind of goes back to a lot of the protocols. The GLOBE protocols really should be taking care of some of this, because the GLOBE protocols have you oftentimes doing 3 different samples. So I think be able to use all of that data, I think that as long as you've already done that data collection for the protocols, you've done 3 samples, you see that variability, you see that repeatability. So I think that's important, but other ones just wanted more data. It wasn't enough to really answer the question. And, to some extent, I think that's taking a little bit more time in terms of the data collection can yield nice results. And to some extent, I think the students will just be more satisfied if they're able to answer the question instead of, well, maybe it looks kind of like this. So a couple other things, and these ones maybe relate more to the aspect of poster design, but one of the things people thought that there's too much text maybe, and there should be more graphs versus pictures. A lot of the ones had maybe a couple graphs, and I've always thought, as I'm teaching science students, that's kind of the meat of the whole project, is the data and the results. And so I want to see a lot of graphs. I think you can go too far, and some of my college students put so many graphs on, it's overwhelming. But I think oftentimes I'll show some examples, and you can kind of see that probably some more use of graphs probably are nice. And then we have kind of the appearance of the graphs, and I won't really go into that in a lot of detail, but I think in terms of getting the right types of axes, making sure you can read everything, I think students it may look fine to the students. They don't realize that some of us reviewers have a little older eyes and maybe need things a little larger. So I'm going to go through just a few examples of some of the projects that we had this past year at our Southwest region in Denver. So this is one that was really looking at microinvertebrates, and they were looking at some water chemistry. So I wanted to show this one. To some extent, they were not exactly, we don't do points exactly, so they weren't docked points, but we had some of our reviewers are a little picky in terms of how just appearance and how things are lining up, and thought it was a little messy. But one thing I liked about this one is compared with bar graph, bar graph, bar graph, here we had several different types of graphs. And I'll go through a few of these, but some of these are, pie charts, kind of stacked column graphs in addition to line graphs. And so this is a very appropriate use of a pie chart. I've seen pie charts used inappropriately, but this is an example. Pie chart or kind of stacked bar charts are really good if you're really trying to look at a percentage. In this case, they were looking at different percentages of different species. I apologize that these are a little blurry. I've translated these from some photographs, and they don't necessarily are PDFs and might not come in really clear, but I think you get the point on these. This one, I think, is looking at these different species collected, and then here I show this similar one, but now using a pie chart to now looking at those different species and how they're traditionally listed in terms of their sensitivity to water pollution. So this is, I think, to me, it's nice to use a complement of different types of graphs and charts that take the same data to some extent and showing them in a different way. So I like this because it shows more all of the data, and it's looking at each of the sample times and how many of each of these groups there were versus an overall percentage. And this one is another one where it is a bar chart, but it's an appropriate bar chart in terms of kind of a stacked columns, where you can look at the number of, and here the previous charts wouldn't have said what numbers. You might be wondering, well, how many mayflies did you find? How many stoneflies? This has all of the data, and it's a much more appealing presentation, I think, than a table. So one of the comments, I think I showed one of the comments that said, well, it would be nice, there's so much information in that table, it would be nice to put that in terms of a chart. And this might be a good use of kind of bar or column charts. So I'm going to go through a few more here, and I just want to skip through these fairly quickly. And part of this is to show the number one comment I got from some of the reviewers was, oh, it sure be good if they didn't see another poster with bar charts. And to some extent, I think one of the good things about the student research seminar, some of the things they're doing in terms of using globe data, collaborating with other schools, all of those things, we want to encourage them and say, that's great in terms of emphasizing the presentation. This was a group that did great on the presentation. I might say, that maybe more use of data might be something that would be useful to have some more data and more, maybe different variety of different types. But I think I'm going to go through a few fairly quickly, but you can kind of see to some extent the similarities we start to see. Here's some more with just a kind of a simple column or bar charts. Here's some more where their data is mostly in terms of looking at bar charts. That happens to be me talking to them. I was not a reviewer. I was kind of organizing the whole thing. Here's another one, and this one I think was really interesting in terms of kind of both the engineering aspect, so they were kind of looking at taking globe data and what can they do in terms of globe engineering aspects, so kind of the E of STEM. And also, they were inspired by their teacher had gone on a globe expedition to Kilimanjaro and kind of came back and had some data that she had taken there and really inspired them in terms of looking at this data, and therefore looking at some globe data from someplace around the world, that G of globe. And so here they are collecting data, and here's the globe expedition in East Africa. So maybe kind of look at this, and this is an example where they're showing some of their data. So I might look at this and say, you know, some of the things I might look at here, I think for novices that haven't done this a lot, I think this might, the scale might not look odd to me. To me, the scale of 7 and 7.35 and 7.7, 8.05 is a little bit odd, irregular, but on the other hand, so kind of irregular intervals, but on the other hand, I think it's good that they scale it so it uses the whole vertical distance. I think so. This one does have the pH, you know, in terms of the vertical axis, has some of the information listed. Here's another one they had down below that didn't have a caption. So one of the things I think that would have been useful here is maybe put those two sets of bar columns and kind of stack those together. They could take, for example, the one on the left. I think the other thing is it's not really readable what the labels actually are. So that's something to kind of look at some of those details. That first one is actually their school tap water, and then they're looking at that before and after. So it might be useful to take the first and the fifth, second and sixth, and stacking those ones to be able to see the how those things are related. So here's one more. So I think what they did here, they were taking a lot of data. To some extent, again, they're looking at lots of different sites. They're using bar charts to look at various variables. And I can look at this. It's a little hard for you to read, and even here, this photograph, I can't really read it. But this is dissolved oxygen, nitrate, pH, temperature, turbidity for these 6 different sites. But I think one of the things they could have done is somehow several different ways they might put this together to allow the reader to make the connections between 2 different variables a little bit better. You could do that with a line graph. You could do with scatter plots. There are several different ways you could do. So I guess one of the things I would say, and I got this from the reviewers, is to really have a variety of different things that we might have. I think I'm pretty close to done. So maybe I'll run through just a few more slides I put together today. I teach meteorology, so I have some data here on temperatures here in Denver for the past month. So this is the month of November. And so this is a type of a column chart, but this has a lot of other information on here. And for each day, the column represents the range of temperatures within that day. And on the background is the pink area shows the record high temperatures each day. So you can kind of see at the end of the month, about the 27th, this was a record high temperature. The blue shows, the bottom blue shows the record low temperature for that date. So one of the things I did is just kind of took this raw data and thought of several different ways I might present that same data. So this is a line chart, and I did these fairly hurriedly, so I may have some well-deserved criticism for not really being as careful as I could be on the axes and some of those things. But I misspelled degrees, so just as an example. So I'm simulating what you might actually see at kind of first version of some of these posters. So this is showing the daily temperatures, both the maximum and minimum temperatures. So you can kind of look at that, and probably better than just a table, you can match up where one of them zigs and the other zigs. When one zags, the other zags to some extent. We can also take that same data, and I didn't mark the axes here. I lost part of it. This is a scatter plot, so I would be careful, but for one thing, let's see. So I took all of these, and this is just the maximum, or this is the maximum versus the minimum temperature. I can look at that in a scatter plot, and I can see that for the most part, the warm high temperatures also go with a warm low temperature. To some extent, it's kind of interesting, I do this with my climatology class, and these are paired data. I'm matching up the high on the second with the low on the second, but I could also do it the high on the second with the low the following day. And as far as causality, this does not show causality. Does the high temperature the day before predict the low temperature that night, or is it the other way around? Neither are a perfect predictor. So we're really looking for a causality here. Or we're not looking for causality, we're looking for the relationship between the two. Okay, so let me show one more, and then maybe I'll see if you have some questions on this. So here's another one in terms of looking at the variability. So this is our variability. We had a very, very warm November. So this is in degrees Celsius, but the 20 degrees, the 21 to on up, those are temperatures in the 70s Fahrenheit. So we had extremely warm temperatures for Denver in November this year. But one of the things we can kind of see here is that distribution. One of the things I would be interested in answering a question on this would be to compare this histogram to an average year or the previous year. How does this distribution change? So in terms of some of the data, didn't really see that much of really looking at that kind of statistical variability. Some other types, of data that I showed way back. Looking at that would be doing these box and whisker plots. So box and whisker plots are another type of graph that shows something related to that frequency.